I know.
For those of you guys just joining us, we chose not to grade our 3.2 homework today, so that way, hopefully, Jaden and Caitlin, and actually Caitlin might be back Tuesday. But Laurel, hope you guys are back with us on Monday. Hopefully you're able to catch up this weekend. Email me if there's anything I can help with. But we'll grade all together on Monday and see if you guys have any homework questions for us to go over. But for right now, section 3.3. We are trying to build up to the puzzles. To build up to the puzzles, to build up to being able to play a game, you need to know the rules. Probably it'll make it more fun if you do. If you build your skills, if you learn how the game works, how the equation works, and how all the key players are able to be used. So, along those lines, we talked about section 3.1. What are exponentials? They're key pieces in equations and graphs and your calculator. 3.2. Who are logarithms? What are their key pieces and how do they and exponentials interact and how can we do them together or apart or change from one to the other? What are we allowed to do with exponentials and logs and who are logs? And 3.3 says, wait a minute, logarithms. There's a lot more you can do with them. So first of all, take the base formula. If I have a certain base, like, how did it go? A?
Log
Of x. It's a fraction, like Al brought up yesterday, right? Who goes on top?
The boomer.
Well,
X.
the argument of the new base, which maybe is an ln, which maybe is a common log. Hold on, I'm going to show you something. Yes. But hold on. An application of this means, remember those two buttons that you have for logs in your calculator?
Yes.
I can do ln of x over ln of a. That is technically legal to change from like a log base 2 or log base 7 or log base whatever. I can do this because of the change of base formula. Or I can do this, the common log of x over the common log of a. And what is the common log of base of? No, that's natural. 10. There you go. How do you know that? Look at your calculator and look above the ln. There's an e. Look above the log. There's a 10. Oh, that's nice. That's nice. P.S. Chemistry people.
Ooh, chemistry. I'm dropping that.
Half-life doubling kind of has to do with this.
Oh, we haven't learned that yet.
Half-life's actually really good.
When it comes, we'll do with this. There you go. But this discovery guy, what's going on down here? Remember how yesterday I showed you guys the Algebra 1 exponent rule books for the bonus in section 3.1 homework? What do we do exactly? What can we do? How can we rewrite? What is truly happening when we see an addition of exponents?
You can make it
A to the power of, do what, Sophia? With multiplication, right? Addition of exponents comes from multiplication of like bases. So I technically can do this, right? So if I have log base a of u plus log base a of v, and I have a to the power of, they cancel out. No, there's that addition that kind of traps this whole thing. But how you can simplify is by multiplication. Wait a minute. Well, if you multiply, hold on. What can I do now with a to the log base a of u? Was that like a property in section 3.2?
Yes, you can add them together.
I can reduce it. I can say a square root of a squared. I mean another inverse. A to the log base a is just u. And a to the log base a is just v. Well, wait a minute. What does that show us? I don't get it. Okay, so this big old nasty thing is u times v?
Yes.
So check it. Ready? So what if this one equals this one? What if I take log base a of both? Isn't log base a of a to the power of just the power? What we just saw was why the property is what it is. And it all has to do with addition of exponents is multiplication of their powers. Oh. Addition of exponents is multiplication of their powers. So that's the whole reason why I can do the sum of two common base logs. I shouldn't say common base because that's the common log, to logs with the same base ends up being a single log of the multiplication. Now hold on, Sophia yesterday brought up a really good point. Was it yesterday or the day before? Asking, I don't know. But she was asking, hey, what if I have, no, she was talking about division. She was totally talking about division. But it kind of works with multiplication too. What if I had log A of u times log A of v? Can I do something there? And the answer is no. So what I need you guys to see. Okay, calm.
Oh, no.
I have addition of logs is single log of multiplication. You're going to hear me say things like single log, getting into a condensed logarithm. We're condensing into a single logarithm coming from a sum of separate logs. So there are parts of the properties that have to do with multiple logs, plural, but then there are sides of the properties that have to do with condensing into a single log. And here's the problem. The single log, the product, can't be multiple logs, and the multiple logs can't be a single log. I know it's going to sound confusing, but I'm going to try to, not try to trick you, but I'm pretty sure you're going to get tricked, and then you'll hear me saying some of this, like single logarithm. Think about the property. What side is the single log? What side is the separate log? Separate logs versus single logs. And that's what you guys are writing. Check it. Each of these. Do you see the single log side? Condensing into a single logarithm, I mean just one log, condensed in, condensed in, condensed in. Whereas over here, I'm talking about separate logs. Sometimes we want it separate because we can't handle them all together in a single. Sometimes we want it all together in a single because we can't handle them separately. So these properties are super helpful because if we can't handle the single, we can make it separate. If we can't handle the separate, we can make it single. We're going to be working both directions. And Emily, it's kind of similar in the ones that you brought up, the trig ones that are coming way down the line after like 4 and 5. Because in those properties, sometimes we want it in the condensed, like tangent equals, and sometimes we want the quotient sine over cosine, but sometimes we want sine over cosine to be tangent. It just depends on the context. It just depends on the context. You want to think about it, we're talking about puzzles and games and all that sort of stuff. If we're talking about like a team and a player who's multifaceted, can do different things, sometimes you want to capitalize on their skill to be, I don't know, depends on the game and the team. But sometimes maybe you need them to be the point guard, but sometimes it's like, nope, we need your height, we need you down low. Depends on their skill set. Depends on the situation. Same thing here. Depends on the situation, the equation, what we've been given, and what we're supposed to do, our objective. Wait a minute. Why am I going to put this whole thing in a big old set of parentheses?
Because you're multiplying them.
It's different, and yet it's really just the
Exact same.
Why is it the exact same? This says any log. This says PS. That includes natural logs. LNs are natural logs, but for some reason, because it's L and N and not LOG base E, people get confused. It's a simplified notation for log base E. Remember, ln of x is really just a log. So he gets to, needs to, is allowed to have all the common properties of a logarithm. I used the word common again. So, wait a minute. Do you remember down here what I said U and V are for this guy? U and V, isn't that the notation for the properties? I have a single log, so look on the single log side, it's a quotient, right? So I can rewrite this guy to be log of 9 minus log of, wait a minute, hold on, the properties say log base. Who's the log base? Oh, this is the common log. It's not there on purpose. It's understood 10. Well, wait a minute. That's all we're supposed to do? It's just, oh, no. It says rewrite and simplify. Like with my calculator? Nope. It's what we can do without our calculator. Well,
You can make it like multiplying 9 putting 3.
Not multiplying though. You guys just said the base was 10, right? It'd be great if I had a 10, but I don't. It'd be great if I have a 10, but I don't. Well, wait a minute. Hold on. Who's in this?
There's a 10 in there.
There's a 3 and a 100. Wait, 100 is 10 squared. Hold on. Wait a minute. Couldn't we have reduced right there? Or if you don't see that, couldn't we technically have done? Is that legal? You could have either reduced up here, but some of us just saw U and V and went for it, so now we're like, oh, stink. But wait a minute, we just said log base 10. I don't mind if I have 100, because 100 is 10 squared. Do you guys see how I can make log base 10 of 10 squared into a 2?
No.
So I can say log understood 10 of 10 squared. Don't those cancel and I just get the 2 left over? The 2 comes in front and log base 10 of 10 is 1. Oh, but I still have stink. I still have the log base 3 and the log base, I shouldn't say base 3, log of 3 and log of 9. Well, 3 and 9, is that something that we could probably do something with?
Yes.
Oh, hey, wait a minute. Maybe I should have kept them together. Wait, how did I just go from separate logs to single log?
Simplified again.
I simplified again. I went back to the quotient property and said, wait a minute, those two, they're a thing. Oh, that's right. 9 over 3 just becomes log of 3. Sorry, I keep on making up the base. It's a common log. Wait, why is it a minus 2? Because it was in the denominator. So the final answer is negative 2. Wait, why would I write the negative 2 in front? I don't understand. It was fine at the end, wasn't it? It might look like it was log of 3 minus 2. It might look like you're supposed to bring them in, but I totally cannot. It is a separate constant being subtracted. So whenever I want to avoid confusion, I write it in the front so I show, no, it's separate, leave it separate. But pause, guys. Wouldn't it have been way easier just to reduce that to be 3 and 100? Oops. Then you would have had log of 3 minus log of 100, and then that would have been log of 3 minus 2, and you would have cut out some work. So maybe they'll give you a problem where you can actually do some math to start, and then, like some simple math to start, and then go from there. But wait, what about this other example? Did anybody catch what I said U and V were a second time? For letter A. But why 2 times 4? Wait, we couldn't do 300 until we split up to be 3 times 100 because it had a log base 10. I wanted powers of 10. Over here, what do I have a base of? 4. I want powers of 4. Well, no. So my base is 4, right?
Yeah.
So I want powers of 4. Then I can cancel stuff out. The problem is 8 an easy power of 4.
No.
Most of us would say no. Just a couple of us might be like, oh yeah, 8 equals 4 to the power of done. It's 3 halves, by the way. Well, I don't have that in my head. Okay, fine. So make it log base 4 of 2 times 4. Because maybe your head can deal with a 2 and a 4 a little bit easier than an 8. My brain says, sure, 3 halves, but to be honest, I think about it with the 2 and the 4 because it's easier. Wait, it's easier? Yeah, because what's log base 4 of 4? What power of 4 is 4? What power of 4 is 2?
1/2.
Because it's the square root of 4, right? And the square root of 4 is 4 to the 1/2. The 1/2 can come down. My brain might be thinking of 2 as being a half power of 4 and 4 being a 1 power of 4 to get 3 halves, rather than thinking about how 8 to the 3, how 8 is the square root of 4 cubed. This is a bit harder for my brain. I would much to think about it as the 1/2 power and 1 power rather than thinking about it as, oh yeah, it is the 3/2 power. Because it's the square root of 64. Anyway, either way you get there. So, what can you do with these properties? We have two options. Let me dual page it so you can see both. We can either expand single to separate, or we can condense separate to single. You guys remember, we're just building our skills. We're going to see problems in future sections where it's like, ooh, I really want to expand right now, or ooh, I can't handle expanded, I need to condense. It depends. We're just building our skills right now. So expand. My way of saying it, pulling apart, yes, but we're going expanding from single logarithms to separate. There's a purpose, there's a plan. You can't see it yet. Just hang in there. And try to work on the skills that are being shown to you. Oh, there's a light plus. There's a purpose, there's a plan. It's coming as to why you need this. But for right now, you kind of got to go on faith and obedience and say, all right. You tell me to expand, I'll expand. Just be aware of what voices you're listening to. You tell me to condense, I'll condense. Wait, condense! Okay, so if that's single to separate, we're going from separate to single. The logs are going to be separate. I'm trying to bring it into a single. So either I'm pulling apart using my different properties, or I'm putting together using my different properties. So if you guys look, don't these kind of look like the log u times v-ish or log u over v-ish? Whereas these ones look like log of u plus or minus log v. Now the examples, they're kind of small. Let me see if I can make them a bit bigger, just for sake of us getting to solve both pages at once. Can you guys kind of see them if I do it like that? These ones, maybe I can do the same thing. Whoa. How does that apply?
It's actually the first limit. Any blank sky?
Ready? Which one looks easier, A or B?
A.
Okay. What properties do I get to use?
The multiplication property.
Okay, that works. It has been multiplied, right? So what operation am I going to go back to?
Addition.
Addition. So does it make sense that this whole thing can be rewritten as log base 4 of 5 plus, can I just write them like on top of each other? Sorry, it's going to be awkward. Plus log base 4 of x cubed plus log base 4 of y. Do you see how that works?
You gotta put the 3 in front though.
So just using product property, I can go from them being multiplied to separating the logs of each piece. And Emily's like, but wait a minute, the x cubed part, can't you bring down the 3?
You just bring this down.
Power property, exactly. So my final answer would be all separated, log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. Have we gotten from a single logarithm to its most expanded form?
Yes.
AKA separate logs with the simplest arguments possible. Expanding is great for getting the simplest arguments. Simpler logarithms means simplest arguments. The argument was just a second ago, 5 times x cubed times y, whereas now it's just a 5, just an x, and just a y. But how about letter B? But is it? What property?
You gotta subtract it.
Subtraction, because I have a quotient property. But can you guys see why I'm going to go straight to the proper answer of 1/2 ln of 3x minus 5 minus ln of 7?
Yeah, because the square is just 1/2.
The square root is a 1/2 power. So I can change the square root to a 1/2 power, bring down to 1/2 power. And division inside a single means subtraction of the separates. Are we okay-ish? So what's going on differently over here? We're trying to go to a single logarithm. Only legal if they're the same base, but they are. They're both common logs. Cool. Do you guys see why I'm about to write x over x plus 1 quantity squared?
Yeah.
The x was just alone, the 2 became a squared, and the subtraction said you go down. Oh. A single logarithm with a single argument. Single logarithm with a single, more complicated expanding is nice to get simpler arguments all broken down. Condensing is nice to get a single logarithm with everything in one place. Depends on the problem as to which one's going to be more useful. So can anyone tell me what the condensed argument will be of the ln?
The form.
What goes on top? You're almost there.
Power 4.
Both of them, right? Just check it. Doesn't it go to both? So up as a power of z and up as a power of z plus 5. But what's down? Alright guys, this homework technically due Tuesday. We're trying to get the rest of our class back and caught up. I don't know. Please guys, try your best to stay healthy. My people that are not healthy, come in and let me try to help.
Sure.
But most of you, to be honest, can probably finish this by Monday. Bye guys.
Let's go to university.
Happy Monday, you're almost done. 3 more periods.